I'm Ms. Kingsley, and this video is about factors, and specifically how to use models to find factors of different numbers. So the essential question is, how can I use models to find factors? Before we do that, we're going to take a look at some vocabulary. Okay, here we go, vocabulary. So what is a factor? A factor, it is a number multiplied by another number to find a product. And I gave you an example here of 2 times 6 equals 12. In that example, 2 and 6 are the factors and 12 is the product. Another important vocabulary term we need is array, and particularly rectangular array. So as you might remember, an array can be used to show multiplication, such as this one here shows, and it can be any different kinds of objects that are shown in rows and in columns. This particular array is again showing 2 times 6 equals 12. We can also use a rectangular array on that you might see on grid paper, which we're going to look at next. And that would look like this. It's still an array, and you notice it makes a perfect rectangle. Okay, I'm going to move to sharing my screen with you so we can go to some example problems. And here we go. So on these problems, we're going to be using grid paper. And if you don't have that at home, but you do have a printer, you could easily find it on the internet. Just search for grid paper and there's many possibilities that you could print a few pages out. So to go to our challenge for today, which is using a model in order to find factors, we're going to start with trying to find factors for 12. So we're going to see how many different arrays can we draw that would give us factors of 12. So I like to have my students start with 1 and move forward with the numbers to see if we can make arrays for them. So let's start here, and we see 1 times 12 gets us 12. So this one would be 1 times 12 is this array. And if I'm going to write this as factor pairs look like this, where they show us the factors for a number. So my first factor pair is 1 and 12. And what that means is if I multiply 1 times 12, it equals 12. So 1 times 12 equals 12. Okay, let's try 2. Does 2 work? Yes, 2 does work. 2 times 6 equals 12. So we're going to put this problem here. 2 times 6 equals 12 is what that array is showing. Make that one a little darker up there. Okay, now we're going to do our second factor pair, and that's going to be 2 and 6. Okay, let's go on and try 3. Can I make an array with 3 that becomes a perfect rectangular array? Yes, I can. So this one, say it out loud. It is 3 times what? Yep, that's right. 3 times 4 equals 12. And each time, if I count up the number of squares in my array, I have to come up with the perfect, exactly with 12. Okay? So let's try 4. What do you think? Is it going to work? Make a prediction. Yep, there we have 4, and we get another perfect array. First, let me get down my factor pair for 3, and that one was 3, 4. And now for starting with 4, I have 4 times 3 equals 12, which you probably knew already from the commutative property. So that makes my next factor pair 4 and 3. Now let's try 5. That's the next number in counting order, and see if that works. Uh-oh, look what happens. I do not have a perfect rectangle. So this does not show us a multiplication problem. This shows us 12 squares, but we have 2 rows of 5 and then 2 left over. So we don't get to use that one. Now let's go on and try 6 and see what happens. Here is, up here, we're going to have 6. And it does work. Say it out loud. What is that multiplication problem? It is going to be 6 times 2 equals 12. So we would go to my factor pairs and put down 6 and 2, which is the opposite order of 2 times 6, as you might remember. Okay, now we're going to try 7. Let's see what happens with 7. Oops, 7 does not work. We cannot get a perfect rectangle for 7, so we do not get to add a factor pair for that. And we can keep going. If I try 8, I have the same problem. I can get 1 column of 8, but I can't get 2 because I go past 12 and I can't have more than 12 boxes in my model. So only the perfect rectangular arrays work. So we have all our factor pairs now right here. So let's take a look at how do we go from factor pairs to factors. And what we do is we take the individual numbers and we list them in counting order. So it looks like this: 1, 2, 3, 4, 6, and then don't forget 12. All right, and then we're done with that one. We're going to do one more example and then I'll give you some ideas for practice problems. So let's take a look at factors, finding factors for 15. Here we go. We're going to try 1 and see if that works. Well, you might be figuring out that 1 always works because 1 times any number is itself. So 1 times 15 is equal to 15. So our first factor pair for any number is always 1 and itself. Let's try 2 and see if that works. Do you have a prediction? Let's see. No, it does not work. And you might have guessed that because 15 is not a multiple of 2. We can't go 2 times any number and get to 15 using whole numbers. If we skip count 2, 4, 6, 8, 10, 12, 14, 16, we don't find 15, so we can't use that one. But let's go on to 3 and see what we have. Well, that one works. So we have 3 times 5 equals 15. And we're going to add our next factor pair, which is 3 and 5. So let's see if 4 works. What do you think? Yeah, it's already not looking good, right? Okay, because 15 is not a multiple of 4. We go 4, 8, 12, 16 would fill in that little white box, but we can't do that. You can only have 15 squares, so we don't get to use that one. So we're going to go on to 5, and there we have it. 5 times 3 equals 15. So we do add that to our factor pairs, and we have 5 and 3. So we're going to go on and check our higher numbers and see what happens. We're going to have try 6. What do you think? Take a prediction. No, didn't work. So we don't get to put 6 down as a factor pair, as a factor 6 in any number, excuse me, as a factor pair because we can't multiply 6 by any whole number and get 15. Let's try 7. Ooh, also doesn't work. If I have 7, the next row is 14. Ooh, I'd have to add 1 to get to 15. These do not show rectangular arrays that stand for multiplication. So our factor pairs for 15 end up looking like this. We have 1, 15, 3, 5, 5, 3. So how we get from there to factors is like this. We take them in counting order and we list 1, 3, 5. Which one did I forget? Do you remember? Yes, the number itself. 15. Always remember to put that one there. Okay, so those would be our factors for 15. All right, almost done. I want to give a recommendation for some practice problems. So my recommended numbers to use for practice using grid paper, start with 16, 21, 20, or 25. These are all good numbers for learning how to do this using a model, using grid paper. So you would go ahead and find all the arrays for a number that are a perfect rectangle, then write the factor pairs, then list the factors in counting order, just as I did. Remember, you can replay this video and stop at any point if you want to look at something again. If you're feeling really confident with those numbers and you want to move on to more challenging numbers, these might take up a lot of space and a little bit more time, and it helps to have more multiplication facts to help you, but you could try 30, 32, 36, and 45. There's some big numbers in the factors of these larger numbers. So either way, try some of these out and see how you do. So I hope that this was helpful to you, and good luck, and I'll see you next time. Bye-bye.